So, BLUP model for stability analysis. So, BLUP is best linear unbiased prediction. So, this statistical method we'll use for prediction of breeding value. So, what is breeding value? The breeding value is genetic potential of an individual. So, here in our case, it is plant, but originally this method was developed for animal breeding. So recently, from this last 4-5 years only, researchers are using this for prediction of genetic potential of plants. Okay, so this BLUP based linear unbiased prediction. So best means it produces the highest possible prediction accuracy. Then linear means it uses the linear model for the prediction. Unbiased, so there are no errors. Whatever the expected and observed values, so both values approximately they will be same. And last is prediction. Prediction means we don't know the actual value, but still we are predicting it. So that is called as best linear unbiased prediction. Okay. So now we will see our graphs. First we will see our graphs and then we will see the stability parameters. So here first we will see this one by one. Yeah. So I think this is visible.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So this is SYKG, that is seed yield, kg per plot trait. And here you can see the 4 different graphs. That is, first one is residual versus fitted value. Second is normal QQ. Third is scale location. And last is residual versus factor level. Right. So this is the first set of graph we will get after BLUP analysis. So if you remember, during AMI and GGE also, we used to set model by using command line. Okay. In BLUP also, if you will see the script, total script, many times we have set the model. I think almost 2-3 times. So this first set of graphs will check whether whatever the model we are using for this particular trade is correct or not. That is the objective of this first graph. Whatever the model we are using for this particular trade, so that model is correct or not, that will be checked by this set of graphs. So first is residual versus fitted plot. So here you can see this residual. So what is meant by residual?
So
Errors.
left.
What left?
The variables which are left, which are not included in the study.
Okay. Yeah. And what is meant by fitted value? Yes. So if residuals are error, then what are the fitted value? So this fitted value is the predicted values for that particular trait. So this first graph is error versus the predicted values. So just 2 minutes before we have made one statement like this, best linear unbiased. So that unbiased we need to see in this graph. So this first graph is residual versus fitted plot. So you can see most of the data points are scattered randomly. So see, this is, you can see one dotted line here, 0, right? And then these are the data points. And one red line is there. So it is showing like, see, this data points are distributing. So the distribution is started from this. Then some are at the 0 line and they are going slightly upward. So from this graph, you can say like they are distributed randomly with slightly upward, which means whatever the model we are using, that is working fairly well. They are not much deviating. Whatever the observed and expected, they are almost equal because the data points are not deviating. Okay. Then this is called as QQ plot. So what is QQ? Yes.
Quartile.
Yeah. So QQ is quantile plot.
Sir, in the first graph, how will we know that which are the observed values and they are in a linear relationship with the original values? But which are the real values and which are the predicted values?
So there are, as I told you, that zero line is there. From that 0 line, your data points are not deviating. Means it is not like one data point is at 1 and other data point is at 1 left. So they are nearby each other. So see, you can, no problem, 1 or 2 data points. Now you will say these data points are far from. So 1 or 2 data points, the maximum your data points are not deviating. These all are nearby each other. So that means your model is fitted well. Just a simple conclusion. Whatever you want the genotypes with values, so be patient. When we'll go to the values, you can correlate that values with the graph. You will get the answer. Just be patient. Let me complete it. So the second graph is normal quantile plots. So here also you can see this is the actual distribution, this red line, this gray shaded red line. So this is the actual deviation of the data points and these black dots are the deviation of our data. Right. So this QQ plot also indicates that the residuals, they are following the normal distribution. They are not deviating. So because see, majority of data points are following the red lines. Right. So the residuals are following the normal distribution. Then now third is scale location plot. So here scale location plot on x-axis there are the fitted values, and on y-axis square root of the absolute standardized residuals. So whatever the residuals are there, so square root of that residuals are there on the y-axis. So what this plot will do, so the plot will check whether the residuals have constant variance or not.
So can you
Here you
repeat this
can
point?
see. Yeah, so this is scale location plot. So on x-axis you will find the model predicted values, that is fitted values, and on y-axis you will find the square root of the residuals. So and then this plot will check whether your residuals have constant variance or not. Then how to read this? So here you can see the red line. Okay, so if that red line is straight, if that red line is flat and horizontal, that means the residual of variance is constant. Here in our case it is different, but if it is flat and horizontal, then the residual variance is constant. If its slope is either upward or downward, so it means the variance changes according to the predicted value. If it is flat and horizontal, variance is constant. If it is that slope is either downward or upward, so means that variance is changing as per the fitted value. And third point we need to remember it that whatever the data points are there, those data points should be scattered around that red line. So here you can see whatever the data points are there, they are around that red line. So here you can see, so this red line, whether it is flat or going downward.
Downward,
Going
then
down.
up.
It's slightly going downward.
Yeah, so it will start from here down and then it is
Slightly.
going
Almost
slightly upward, right? So that means whether the residual variance is constant.
No, sir.
No, sir.
No.
No, sir.
Yeah, so that residual variance is not perfectly constant. So, but here if you will say like in for some data points it is showing flat lines. So in that case, you can accept this model. So then next is residual versus factor level plot. So what are the factors in our case? What are the different factors in our data?
Plant size. Let's move.
Huh? What is our data all about?
Stability, sir.
Sir, SOI kg.
I am asking data. I am not asking character name. I am not asking the aspect. I am asking about data.
Different genotypes.
Yeah. And again, second factor.
Environment.
Yeah. So our major factors are genotypes and environments. So this plot will show the residuals for each factor level. So on x-axis, you will see the different factors. If you will increase it, it will show. Then on y-axis, you can observe the residuals. So how if any residuals are there, then how will you find the residuals? What is the formula for residuals? If I'll give you 1,000 rupees, you will return me 700 rupees, then what is the residual?
Sir, expected value minus observed value.
Yeah. So 1,000 minus 700, it is 300. So that is the residual. So now what is the, why we are going for this residual versus factor plot, factor level plot? So here we need to check whether whatever the errors or residuals are there, that should be spread across all the factors. Whatever the factors are there on x-axis, so this data point should be spread across all the factors. So if the residuals are balanced, like some are in on positive side, some are on negative side for each factor, then that model is called a fair model, means that model is performing well. So if you will say like more positive, mostly positive or negative residuals, so if it is distributing equally, then no problem. If either positives are more or negative residuals are more, so it means that model might be biased for that particular group. Here in our case, that group means that particular trait. So then, is this residual pattern is showing any clear pattern?
Excuse me, sir.
Yeah.
Yes, sir.
Sir, this dot point is a genotype. Like, is the standard the curve is between a standard residual and
It
factors.
is, madam, actually, it is same like what we used to get in Jivas.
Okay.
Like in genome wide, like it is the same. That data points are here represented by these dots.
Okay. Data points like
Across all the, now as I told you, on x-axis
mhm.
different factors are there. So on the basis of that factors, so these points
Yes, sir.
they are showing. So in now,
Yes,
as now
what
my
these points are, I want to know, like what these points are. Are they genotype or something else? What these points denote? The point is the genotype?
yeah, this you are saying these data points, no?
Yes, sir. In the point.
Yeah. They are the means to say whatever we are predicting the genetic potential of each genotype. We are ultimately our aim is to predict the genotypic potential of each genotype. So that these are the distribution of the residuals. So here these are all the residuals. Their distribution is normal.
Okay, sir. And the residuals are the value what we left. I think these are the kind of error, something we cannot control.
Yeah, mainly if you can see in this normal QQ, madam, this all these genotypes distribution, you can see it is normal distribution. Majority maximum it is normal distribution, so that error is minimum.
Yes, sir.
So that is, it is you can consider either genotype or coordinate of that particular genotypes according to fitted value and residuals. So these are all the genotypes. So it is placed according to the predicted performance. Yeah. So my question is, in our residual plots, residual versus factor plot, level plot, so whether it is showing any clear pattern.
Sir, as it is going to the right direction, it is coming more closer to the zero value.
So see, it is zero value, but some are positive side and some are on negative side. So is it a clear pattern?
Yes, sir, it is
Yes,
a
I
clear
think so.
pattern.
Yeah.
Sir, approximately equal number of genotypes on both the sides of that particular line.
So that means this model is treating each genotype.
Like we can say like that the what the
Nice.
The
model
model
we
is
are
performing
using
well.
is working with this.
So that means whether we can say like this model is treating each genotype in same manner.
Yes, sir.
And whatever the data points are scattered across the factors, they scattered randomly. Some are on positive side more than zero and some are on the negative sides. So means unbiasedness is less. So then so this is the next graph. Blobs for genotype, blobs for genotype plus G into E. And third one is blobs for G into E. So now, can anyone tell what is the distribution of genotypes in all the three graphs? Just concentrate on distribution.
Normal.
Yeah.
Normally distributed.
So as these data points are following normal distribution, so that means the blobs are the reliable and suitable for comparison of genotypes. So what are the genotypes? What are the values that we will see when we will see that calculations? So here simply we can conclude like the distribution of data points, they are following the normal distribution. So that means the blobs are the reliable and suitable source for comparison of genotypes across the environment. Yeah, and then
Excuse me, sir.
huh,
Sir, what this gray line indicates? This one?
these are the what are the normal values. So what we'll say like expected values. Some threshold, or we, if I generally we used to say this XYZ crop is 100 days. So that 100 days is threshold value. But sometimes any variety will go 80 days, 120 days. So that is deviation from that normal distribution. If someone is giving 99 days, so nearly it will follow the normal distribution. So it is like that.
Sir, second and third graph is clear, but how we will consider first in the normal distribution?
Yeah. So here you can see second and third is clear. Okay, no problem. But all this, whatever the red line, so total gray shade area, here also you can see all the data points as it is slightly fluctuating, but they are not going outside the gray shade. If you can see, they are not going, it is well matching with the expected line. It is not going outside like here or here somewhere. You can say like approximate, because as compared to these two, because these two are exactly following the red line.
Yes, sir.
So our next is, it is this one.
Sir, excuse me, sir.
Huh?
Sir, in second and third graph, the three upper dot line and lower two dot line, what they represent, sir?
So maybe some outliers. Maybe sometimes some data points, maybe they are the outliers. So that's why they are deviating.
So, sir, in graph second and third, there are some point that is outside the gray set. So we
Yeah,
can
yeah,
say
yeah.
like these are the outliers.
Maybe. Because see, it is second graph is genotype plus G into E interaction.
Yes.
So wherever interaction is there, so see here also 3 points, they are deviating from the normal distribution. Yeah. So this is, both graphs are same. One is colorful and one is like reverse image. So don't worry about that. You can just take this colorful diagram. So this is the ranking of genotypes based on the genotypic performance. So likewise, whatever the which genotypes are above average, which genotypes are below average. So likewise, the rankings are there. So just like you can see, 614, that 905, 1520, 5-18, that 992, 519, whatever up to this 731. So all these genotypes are better performing than the average. While that 80, 70, 2014 one, they are the poor performance. So that is the ranking of genotypes. So here you can see these dots are the genotypes. So what about these bars are there? So these bars are called as error bars. Whatever the bars are there, so that bars are called as error bars. And whatever the what is the meaning of that vertical dotted line?
Average
Threshold
value.
Anyone?
value.
Average value.
One vertical dotted line is there. If you can see the screen here, from 1 it is starting the dotted line.
So it is a
That
Sir, average value.
a threshold value.
Yes, sir. Minimum up to that
So
level.
here in our case it is not threshold. Here we are seeing, we are ranking the genotypes, like which genotype is more than average and which genotype is less than average. So that is the average value line. So here is on these are the genotypes in blue and red color, and on either side that bars are there. So that bars are called as error bars. So here I will show you some other diagram where you will see the length of error bars are varying. I will show you some other character.
Sir, the error bars here it is coming. Actually, the average performance it is above the average performance for blue dotted lines, but error bars are coming in different environment. It is performing different. That way it is coming here.
There is the environment here.
Sir, but why error bar is coming means fluctuating the performance of that particular genotype, deviating. That's why error bar is coming.
Error. That point. Errors will come, sir. How you can control the environment?
Yeah, that is, sir, due to the environment. I am asking, sir.
Yeah, that uncontrolled variation in our normal case, it is standard error. Here they are using more standardized term, that is error. But so that means we can take like from this to this for this genotype. And second, though it is showing some for some genotypes except one first genotype, for the next genotypes they are showing like it is coming less than one. But here you need to consider this. That's why I told these these lines on either side, they are the error bars.
Okay, sir.
I will show you some other graph where that lines are less or more for some genotypes. Yeah, in that WAAS we can see it, so no problem. So here, according to this, 614 is superior performer and MAUTS 80, the performance of that genotype is poor.
Poor.
This only you need to interpret which genotypes are above average and which genotypes are below the average, and this is the average line. So then this is principal components. Like total 7 PCs are there. So this orange one, it is eigenvalue, and then this percentage. So these are the graphs. So maximum here you can see the percentage. The first two principal components are explaining the majority of variation. So after PC3, that variation is become negligible. So that means the first two or three components, first two or three components are enough to understand this G into E interaction clearly. No need to go for all 7.
Excuse me,
As
sir.
here,
So what is the green line showing? The
percentage, variance percentage.
Okay, sir. Then
So likewise here, see, this is for PC1. This point, it is more than 50%. If we'll go for first two principal components, it is more than 75.
Okay, sir.
So on the left side, it is eigenvalue, and on right side, it is accumulated variance. So first is more than 50, up to second, it will be more than 75. That means first PC is showing almost 51%, second PC is showing 27 to 28% variation. Both will cover more than 75. Here that
so we need to add.
Yeah. Here that explain variance is not given. Here directly accumulated variance is given.
Okay, sir. So we add like it may be 50 and then it's 75 is coming, and then what is coming that is lower.
So here just we need to conclude that first when see this is first 3 PC, more than 80% variance already explained. So from this we can interpret like first 3 principal components are enough to understand the G into E interaction for our data set across the environment. That is the meaning of this graph. Below you can see the 7 PCs, left side eigenvalue, right side accumulated variance. Not the individual variance explained by the principal components. So this is the graph. Then so this is WAAS analysis. So it is again the ranking of genotypes by using the WAAS model, that is weighted average of absolute score, which will take the mean performance along with the stability. Okay. So here you can see there is no threshold or average line is there, right? So I will check for yield only because earlier graph we have seen for yield. So for that yield only I will take. Yeah. So means you will understand easily. Yeah. So here I think it is not visible. Yeah. Now it is visible. Yeah. This is for a ranking according to WAAS model. So this model will take not only mean performance, but it will take stability also. So the concept is same. Like blue is above average and red is below average. But here, as this is not based on only the average value, that's why that line is not there. So here, as I already told you, the length of error bar, if it is so there are some genotypes are having wider bar, some genotypes are having lower bar. And if you will see the MAUTS 80, so it is almost showing index 0.
Yes, sir.
Yeah, then 70, it is nearby 0. So as it is not based on actual mean performance. So it is based, ranking is based on WAAS index, as it is one of the stability index.
Sir, what can be
So,
compared from? What can we compare it from, like what it denotes, like compared to other genotype?
so whichever are the above, whichever are in blue line, they are showing high index, so those are more stable. Whichever below, they are showing less index, so they are less stable. It is based
Sir,
on
what
that
exactly
index
this
value.
index value? Sir, what exactly this index value
So
is?
this is WAAS, that is weighted average of absolute score, just like we have seen in AMI. So it will, that index is calculated by taking mean performance and stability of that genotype across all the environments.
So, could you please kindly explain this importance of this error graph, error bar?
Yeah. So here in our first graph also, we have seen the error graphs, error bar, not graph. And here also you can see the error bars are there. So the length of the error bar, it is increasing or decreasing?
So, it is maximum for first genotype.
So it is decreasing according
Down.
to the ranking.
Right, sir.
Yeah, and in our earlier case, so it is this way, it is almost same.
Right, sir.
So these error bars in WAAS model, they are indicating the reliability. But that is reliability of this genotype. As I told you, it will consider mean performance as well as stability. From that index, they are giving more stable and superior performer, or you can say consistent performer. So that means if any some of our friend is, if you will tell any work to him, so 100% he will do. So what we used to say? No, I told him, so he is reliable. He is reliable person. We can rely on him. So in that way, this error bars in case of this WAAS model, it is showing the reliability of genotypes across the environments.
Okay.
Yeah, and then this is heat map. Heat map. So see, here you can see on left side, genotypes are grouped into 4 clusters or 4 groups.
Yes,
So this, yeah, so this is also one of the part of WAAS model. So in right side, here you can see the WAAS score and their different colors. So based on these colors, here you can see groups are there. The genotypes are showing the same pattern, groups are there.
Sir, is there any
Across,
significance of colors of genotype in the
no,
grouping?
no,
It says like
just
black.
this is just classification of genotypes across 7 principal components based on this WAAS value.
Okay, sir. Sir, I'm asking because KDS 992 and AMS 139, they were the in previous analysis they were like
So if you
stable
will,
lines,
if
they are
I
nearby
think you
origin.
have remember, whatever the genotypes are there in this cluster, last cluster, 731, 992, 139, 518, 519, we used to interpret like all these genotypes are almost nearer to the origin with minimal discrimination
Yes, yes.
across
So
the environment. So all those genotypes are there in one group.
yes, yes.
And whatever the genotypes, they are scattered, means far from the origin. So here you can see in blue, like 335, 71, 710, 725. So just it is classification across 7 principal components based on the WAAS values. So now we will correlate it with our actual analysis. Just you can open the text file of BLUP. One text file we got from BLUP. So this file, like this, stability parameters are there. So first I will tell you what is useful. So here, one by one, we will see from starting. So first and foremost thing, you will get this variability parameters. Okay. Then next, whatever the, yeah, so the three graphs we have seen, like blubs G plus G into E and blub G E. So all the values for all the three graphs across all the environments. So total entries, these values are here. All these values are here. And from that, predicted values also, after analysis, these are the predicted values for each genotype across each location and replication. So these are the blobs for 3 and then predicted values, not observed, predicted values, not expected. Then these are the these are the PCs, and like we have got during AMI, these are the WWS parameters. The main thing where it is. So come at the last of this file. So here you will get some stability parameters are there, like HMGB, RPGB, HMRPGB and HMR and RPGB. So just once I think last week I have shared one Word file. So if you have that, please can you open it and see the expansion of this. So this HMGB. So this HMGB is harmonic mean of genotypic value. HMGB is harmonic mean of genotypic value. And that underscore R means ranking on the base of that harmonic mean. Right? Then RPGB is relative performance of genotypic value. RPGB is relative performance of that genotypic value. Then RPGB underscore Y. So that is relative performance of yield. Here we have taken the character yield. So relative performance of yield. Then next is RPGB underscore R. That is rank based on RPGB. Then next is HMRPGB. That is, it is combined index harmonic mean of relative performance of genotypic values. So these are the different stability parameters from BLUP. So here in first column, you will get mean values. So from these mean values, can you tell which genotype is superior performer? Only from this mean value. Don't look at the other factors, only mean value. Yeah.
The genotypes having more than one core.
So just simply to interpret it, just you need to see this rank. Already ranks are given on the basis of this harmonic mean and relative performance. Right. So here, as we have seen in that graph, MAUS 614 is topmost, isn't it? So here check MAUS 614. This is MAUS 614. It is having highest mean performance. Harmonic mean is 1.09. Then likewise all these values you need to interpret it. You need to interpret this blurb on the basis of the ranking given. As we have seen, MAUS 614 is above average. Where is that graph? Yeah, so see here. Which is the topmost genotype?
MAUS 614.
And second?
JS 305.
9305.
Okay, so just now we will see our data. So just say MAUS 614, see the ranking. This is on basis of harmonic mean. This is on basis of relative performance. And this is on basis of combined index. So the rank of MAUS 614 is?
First.
Yeah.
One.
So
First.
yeah, all this interpretation I will send you by tomorrow. You will get AMI, GG, biplot in one file. So don't worry. Yeah, and then our second genotype.
JS 9305.
Yeah, so just here you can check it.
So with these two genotype is like data analysis, can we say like that if the ranking is nearby one is more stable and high
No.
performing?
We have evaluated 22 genotypes. So
Uh-huh.
on the basis of block model, that model ranks that genotype on the basis of their performance.
Oh, sorry, their performance, yeah.
Yeah.
But can we say like that if the value is coming near like one, is a higher performance
No,
nearby?
that
No.
MAUS 614 is the top performer in your lot. That's why that rank is coming as 1. So that rank is 1 because the performance of 614 is on higher side.
Yes. So those
So
who are
see, at last 80. Its rank is 22. That means that performance and stability is low.
yes. So
So
as
just
the
you
value
need
increase is going like it's not stable. Can
Yeah.
we say that? Yeah. Okay.
Yeah, just like ranking from 1 to 22 or somewhere if you are evaluating 100, so it will be 1 to 100, 1 to 50.
Okay. So one is the good, like one is the best performer, and
Ha.
and if we go with the 22, then
One
like
One means our gold medalist, then silver, bronze, so like that.
Yes.
Lastly, that last fellow will get the just the ribbon, not medal. So it is
Yes.
like that. So simply, in simple way, you need to interpret this table based on the ranking. So now just see one, just I am preparing one, so that thing I will show you. 1 minute, let me open that. Yeah. So whatever we are studying, so just now today I started this yesterday. I am preparing one, that is multi-trait model based assessment of selection efficiency. So what are the multi-trait models for selection efficiency?
FAI plus
Yeah.
MGDI. It's
Yeah. Third one.
MSTI.
Fourth one.
MGIDI.
So say
FAI, MGIDI.
So first one is our MTSI, right? Second, it is MGIDI. Third, that is MTMPS. That is, it will take mean performance and stability. And last is the selection method by using BLUP values. So here in this, I have gone through I analyzed with all the 4 models. And simultaneously, I have given the same data, that same data set, that interpretation I am saying. So first, I have calculated the mean values. So all these data will get here, where you will get in this file. Yeah, so see, standard error, standard deviation, coefficient of variation. Then here you will get the minimum value. Yeah, so as we are saying, MAUTS 80 is the poor performer. So you can cross check here. This MAUTS 80 having less value. Maximum 1.68, JS 9305. Then again, you will get the minimum value in which environment, maximum value in which environment. Then genotypes. So this data will be here. After that, then this analysis of variance across the environment. Then just now what we have seen. Then this is the Pearson correlation coefficient that we will see. Then these are the factor analysis what we have done till now. And then this is the PCA. So this interpretation I will share with you. So just you can correlate with it, values and whatever is written. So in short, this is all the BLUP analysis. So now you can compare, like you can write, if you have multi-location data, you can compare all these selection methods integrating with BLUP. Okay, and whatever the correlation I have shown to you, so this correlation is on the pooled data. So what is meant by pooled data?
Mean over all environments. Mean value.
Yeah, yeah. So if you have three, if you have four environments, so total mean of those values. And how will you calculate the pooled replicated data?
Mean over replications.
Which single replication or both replication?
So both replications.
So both replications, then you will get pooled mean value. I am asking pooled replicated data. Yeah, anyone?
Same replications of all the environments.
The
Taking the
pooled,
mean of the same replication of all the environments.
Raj.
the pooled replication is so among environments, sir. Na?
Come again?
The so that pooled replicated data we consider among environment, na, sir. To mean performance in different environment across the replication. So that is pooled data.
Yeah, pooled mean is fine. I am saying pooled replicated.
So, sir, then we have to combine the across the replicated data only.
So like we will pull the data of replication 1 from environment 1 and 2, and for R2 from 1 and 2, likewise.
So we generally use pool data, like we pool the mean value of replication of, different, we pool the mean value of different replications. Sir.
Yeah, generally we used to do pooled mean only. But just you can, what you will say, you can check with your pooled replicated data also. You can do, you can do that whatever your experimental design like RBD or augmented, whatever it is, just you can check it with. So for pooled, nothing, just whatever the file we have, we are doing 1, 2, 3, 1, 2, 3, just you need to sort it according to environment and replication, and you need to calculate the mean. You will get the pooled replicated data. With the format we are using, the same format, you can easily calculate the pooled replicated if needed. If not, then no problem. You can calculate the mean value. So, that is all about AMI, GGE, BLUP, and different selection methods. Dr. Sir.
Sir, you have told me that how to normalize the data to find out the
Yeah, normality script I will share before ending of class. I will share in groups.
Okay, sir.
Normality and Eberhardt and Russell both.
Okay, okay. Sir.
So this is about all three scripts. Wait, I will share for that from tomorrow's that molecular. Give me 1 minute.
Excuse me, sir.
So
Do we
it's-
study about diallele analysis in this?
Yeah, in heterosis we will see line into tester, diallele, both.
Okay.
Sir, could you
Yeah.
please suggest any paper or any article on this so we'll get
Stability.
clarification? Yeah, all the stability, blobs and all.
Yeah, so already I shared one paper, recent one to that is 2025, and I will share mine paper also. I have submitted it to journals. So both 2-3 papers I will share by tomorrow.
Okay, sir. Thanks.
So
Thank
that you can, so that it will be easy for you to correlate with values and descriptions. So it will be easy for understanding.
Yes.
will share that scripts on me. Again, you need normality, na? So just kindly download all the files, that is farm CPU, MDP traits, MDP genotype test, HMP. Just download each and every file. Farm CPU, GAP8. I'm sharing in group.
Sir, farm CPU, which file is it? It is not text, right?
1 minute. That is, I think, a giving problem. Just give me 1 minute. I have shared it. So apart from that, just download everything. I will share that again. Yeah, for farm CPU, just download this new file. The normalization. Normalization, I'm not getting it. I will see that. Yeah, so for alpha lattice, give me 5 minutes. So just open that script. Which script? 1 minute. Yeah, that gap farm CPU file. And just install the packages. Meanwhile, I will share the remaining scripts. Install the packages. If command line is not working, go to tools option. So just install each and every package. Yeah, just accept LD heat map because that LD heat map is not available for the latest version. If you have run it, you may come across the error that it is not available.
Yes, sir.
Yeah, so accept LD heat map, then proceed. And I will give after installation, just let me know. I will give some introduction.
Sir, what did you suggest for LD heat map?
Don't run that.
Okay.
Actually, this is code I prepared long back during my PhD, so that LD heat map is not available for 4.5 version.
Yes, correct. It's saying the same.
Yeah. Yeah, and one more thing. 1 minute, I will show you that. If you have Tassel software in your system, then fine. Otherwise, download Tassel software also. I will show you once.
Can you spell the word tassel, sir?
I will show you. I will show you. Just give me a minute. So yeah, if you'll go.
Excuse me, sir.
Yeah.
Sir, in
So this
in
is
my note, there is no showing mult test also.
1 minute. Let me complete. I will come. You can proceed with other packages.
Okay, sir.
So this is the spelling. So math genetics or directly, if like this link is there, just click on it. So like this window will be there. So just download it. Depends on your system. If Mac OS, separate version is there. For 64-bit, separate version. For Linux, separate version is there. So just download and install the software. Let me check whether I have or not. I will also download it. I don't have anything. You just click on it. It will start download. So we will see this mapping with R and with Tassel with both the softwares. As many of you are aware that genotypic data will come like ATGC, that is in form of our nitrogen bases. So for some part, we need to convert it into numerical data. So that conversion also we will see. So along with this tassel again, one more is there called ICI mapping. So that also download it. Here it is showing 3 by 3.3, but I think latest version is 4.2. Just click on it and just go to the website.
So while downloading Tassel software, it is showing the warning, sir, that running this app might put your PC at risk. So, shall I run it?
So if you will install any software, that warning message will be there.
Okay,
so no problem. Not just Tassel. If you will install any video games, also it will come for any app. Yeah, so latest version of ICI mapping is 4.2. So it is free version, so just download it. So first packages in R, then second Tassel, third is this ICI mapping.
First one, which one, sir?
This one, this codes I shared now.
Oh, okay, sir.
You can download anything first. It is not mandatory. You can download Tassel first, no problem. Because it is 130 MB, sometimes depends on network, it will take some time.
Sir, I lost my connection earlier. What all packages I need to download in R?
That text files I have shared, so that packages you need to download. Okay.
Okay, sir.
Secondly,
Okay, sir.
you need to download this Tassel.
Sir, here I heard.
Then third,
From here I
this
heard.
ICI mapping.
Sir, after going to the website of ICI, then where we have to go, sir? Home.
So you came here. Here.
Yes, sir.
So here, just go to software. And here, secondly, you will get QTL ICI mapping version 4.2.
Okay, sir. Thank you.
So in this code, some packages will show the error, so that we will solve, no problem. So whatever is possible, just download it. Because in latest version, is BIOS manager installed clearly?
Yes,
Those
sir.
who are installing
Yes,
these
sir.
codes, okay.
Yes, sir.
So if some packages are showing error like this command, so we will install it with the help of BIOS manager. So don't worry. So just download that Tassel and ICI mapping, everything, and after downloading, just install it.
Sir, in ICI mapping, we have to download QTL ICL mapping version 4.2.
Yeah.
So on clicking on that, it's again going to that moment.
So I click. So now just see what I will do. My network is slow today. Yeah. So like this.
Yes, sir. So
Okay.
then we have
So
to do
your system is 64-bit or 32? I think
64 bit,
64.
sir. 64.
Yeah.
Acha, okay,
So
sir, I
just
got it.
click.
Okay.
So this is all the requirements for genome-wide association, and that genome-wide association we will do using
Sir,
4 models.
sir, after reaching this page, where we have to click?
Which place?
The which?
This place?
Yeah, yes, sir. The screen you're showing.
64. 64. Maybe this software will not run in some systems. Because
So there
in
is-
many new systems, while installing, it is showing error. So that like it is showing like window don't run or don't install, something like that. So just download it. I will tell you tomorrow how to install it. So don't worry. You can install Tassel easily. It is very simple. Where is Tassel?
Sir, for Tassel, it is showing Windows protected your PC. So shall I run it anyway?
1 minute. Let So just see, this is the Tassel. So like this it is coming.
Yes, sir.
Yeah, so no problem. Just click on that anyway. It will start it.
Okay.
It will start the installation. Just same you can try for ICI mapping. So then this type of installation it will start. Just accept the agreement. So it will start extracting the files. And then finish. After that, simply search it and open it. Yeah, Ragini. So Tassel version
Sir, for Tassel, we need to
5.2.9.
download
Yeah.
into 64-bit.
Your voice is not clear.
It's a 64-bit.
Yeah, it is depend on your system. If your system is 64-bit, then you need to download that 64-bit.
Sir, is it written in doc into 64?
Okay, sir.
What?
Is it written as doc into 64?
I'm not getting what you are telling me.
So you can once again open that QTL ICI mapping. So where is it 64 you are saying, sir?
64 and 86.
So we have to go for 86.
64.
Okay, sir.
And in Tassel, majority of systems are 64-bit, so just go with it. So from tomorrow onwards, we will start using this everything along with the text files. That is MDP traits, MDP genotypes. Then again some database, genomic database we will explore. For finding out the annotations of different markers. So this Castle and ICI mapping downloaded clearly.
Yes, sir.
Yeah, and in scripts also, I think it is problem with only multi-test or some systems.
Yes, sir.
Yes, sir.
So that I will solve, no problem. So don't worry about multi-test error. Prior reading, genome-wide association study. You can go through any paper, Purva. Any basic paper you can go through.
Sir, for TASL, it is showing like you must need administrative privileges to use this.
No, click on that more information, and after that it will come like run anyway.
After clicking on those, all it is showing like that. Sir.
I have already given it. Wait, I will uninstall it. I will show to you. Do me a minute.
Okay, sir. Thank you.
Yeah, now see it. This is my downloaded. I think I have given the permission. That's why it is not coming. Just you can share me the screenshot.
Okay, sir.
Excuse me, sir. From
Yes.
which site we are downloading QTL ICI mapping?
Just you can type, madam, ICI mapping software.
Sir, it is showing two options, X64 and X86.
I already told you need to download 64.
Okay, sir.
Yeah, if you can access the chat box, that link is shared by Dr. Rakesh. So from that also you can take. And you need to download version 4.2. So So first, we will start with the genome-wide association study. Then we will go for tassel for association mapping, and at last we will go for QTL mapping.
Sir, what did you say, sir? So first tassel, then?
First genome-wide, then tassel, then QTL mapping. So like that we will go. Like one by one, we will cover everything. If you want to read it, some people, so just they can, yeah, Selvarani madam, if that these kind of options are there, just you need to give, if that update commands will come, just you need to say it all, that is A, you need to type A.
Okay, sir. Okay, sir, I will try.
Yeah. If you will type A, then it will start updating whatever some minor packages will be there. So they will update automatically.
Okay, sir.
Yeah. So just whatever the packages are there and software, just be ready. And meanwhile, I will share this all three model stability, some 2-3 papers and one separate file with diagram and description like that in that pattern. Okay, so all the downloads are completed.
Ongoing, sir.
Okay.
So, sir, record tassel and QTL ICA mapping and all the packages you are telling.
Yeah.
Packages is still for which script? All the scripts.
Whatever the packages are there in script, so just you need to install it.
Yes, sir. One by one, I'm doing that.
Yes, sir. I will see for that structure software. For that, I will collect that diverse data set, germplasm data set from my colleagues, and then from that data set, I can show you actually what is the structure analysis, because I have that real population data. So that real population data, it will give you understanding, but actual structure analysis is we need data of diverse germplasm. So tomorrow I will collect that, and if possible, we will start with that. I will show you the structure software also. That structure is available on Stanford University website. Okay, so just be ready with all these downloads. That structure website is loading for me. I think some network problem from my side. If you can access the Stanford University website, so on that from that you can download the structure software. So just download it. So
Which version it is? 2.3 is the latest?
So actually, sir, that website is not accessible. It is still loading. I don't know what is problem with me. So whichever the latest is there, just download it.
I think it's 2.3.4.
Yeah, something like that, 4 or 5 something. So just download it.
Okay.
So, can you write the name of the software on the chat box?
Website, huh?
The name of the software that you require us to download.
Structure. So already
Structure.
this tassel see. First is tassel. Second is ICI mapping. Yeah. Dr. Kaushik shared the Stanford University software link. So just you can use that. So we will cover all these 3-4 softwares and we will do structure analysis along with association mapping. And we will cover this. We'll try to cover as much as we can this molecular building aspect.
Sir, for structure, you mentioned about 2.3.4 version.
Yeah.
Okay.
The link is there in chat box.
I actually have it, but I was asking whether it is
No,
latest.
that is only latest one.
Okay, thank you.
Excuse me, sir. Are we going to use QTL ICI mapping for QTL mapping, or we are going to use others as well, like QTL cartographer or
First we will see ICI mapping, then we will see the cartographer.
Okay, sir. And is there any possibility to do with the RQTL, if possible?
So script is there, madam, but just I need to check whether that script is correct. If that is correct, then I can show you and I can share that script.
Or you can just show me how. Okay, I think in the first day of class you saw. So I will go there and then I will try to.
Yeah, no problem. If that script is correct, so definitely I will share RQTL script with everyone and I will show you how to run it. No problem.
Okay.
Okay, guys. So tomorrow, please try to join on time. Don't be late. Otherwise, again, I need to come back and I need to start. So it will disturb the flow. So just try to join by 6:15. Yes, sir. Dr. Sir.
Sir, actually, I have opened from this link structure software, but unable to download. Where is the actually link? I didn't find.
So I will WhatsApp you because for me also that website is loading only continuously.
Yes, sir. Okay, no problem.
I will WhatsApp you, sir. Don't worry.
Okay, sir. Okay.
I'm also getting the error in downloading.
Yeah, Sam. I don't know what is the problem. If I'll get the software from my friends or anyone, then I will share you directly. Just you can download it. Okay, so just try to join on time, 6:15, working professional specially. Because students can join, but working professionals just try by 6:15 so that our workflow will be maintained. Okay, so tomorrow we'll meet at 6:15 and we will start this molecular breeding section. Thank you, everyone. And by tomorrow, I will share this stability interpretation also, all 3-4 models. And we will start with molecular aspect. Okay, thank you. We will meet tomorrow, 6:15.
Yes, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.